Introduction. Factors. When an algebraic expression can be written as the product of two or more algebraic expressions, then each of these expressions is called a factor of the given expression. Factorization. This process of finding two or more algebraic expressions whose product is the given algebraic expression is called factorization. Remember, factorization is the reverse process of multiplication. Common factors of monomials. Let us consider the monomials 18a cube and 27a square b. Factors of 18a cube are 1, 2, 3, 6, 9, 18. A square, a cube, 2a, 3a, 6a, 9a, 18a, 2a square, 3a square, 6a square, 9a square, 18a square, 2a cube, 3a cube, 6a cube, 9a cube, 18a cube. Factors of 27a square b are 1, 3, 9, 27, a square, b, 3a, 9a, 27a, 3a square, 9a square, 27a square, 3b, 9b, 27b. Therefore, the common factors of 18a cube and 27a square b are 1, 3, 9, a square, 3a, 9a, 3a square, 9a square. Example, find the common factor of 7p cube q and 5p q. Solution, 7p cube q and 5p q. Factors of 7p cube q are 1, 7, p, p square, p cube, 7p, 7p square, 7p cube, q, 7q, pq, 7pq, p square q, 7p square q, p cube q, 7p cube q. Factors of 5pq are 1, 5, p, q, 5p, 5q and 5pq. Common factors of 7p cube q and 5pq are 1, p, q and pq. The highest common factor HCF of monomials. HCF of two monomials is the product of the HCF of its coefficients and HCF of its variables. 12p square and 6p cube. 1. The HCF of its coefficients 12 and 6 is 6. 2. The HCF of its variables p square and p cube is p square. 3. Product of the HCF of coefficients and variables is 6 into p square, which is equal to 6p square. Hence, the HCF of 12p square and 6p cube is equal to 6p square. Example 1. Factorize 64a square minus 8a cube. Solution. 64a square minus 8a cube. The HCF of the 64a square and 8a cube is 8a square. So, 64a square minus 8a cube is equal to 8a square into 8 minus 8a square into a. Writing each term of the binomials as the product of HCF and a monomial is equal to 8a square into, in the brackets, 8 minus a. Writing the terms as the product of HCF and a binomial. Example 2. Factorize the following: x cube plus x square plus x. NCERT. Solution: x cube plus x square plus x. HCF of x cube, x square, x is x. That is the literal factor with the least power. So, x cube plus x square plus x is equal to x into x square plus x into x plus x into 1, which is equal to x in the brackets x square plus x plus 1. Factorization of algebraic expression having a binomial as a common factor. Example, factorize a in the brackets 2a plus b into x plus in the brackets 2a plus b into y. B, x square into in the brackets x minus 1 plus x minus 1. Solution, a in the brackets 2a plus b into x plus in the bracket 2a plus b into y. Common binomial is in the brackets 2a plus b. So, in the brackets 2a plus b into x plus in the brackets 2a plus b into y is equal to in the brackets 2a plus b into in the brackets x plus y. B, x square into in the brackets x minus 1 plus x minus 1, which is equal to x square into in the brackets x minus 1 plus 1 into in the brackets x minus 1. Common binomial is x minus 1, which is equal to in the brackets x minus 1 into in the brackets x square plus 1. Factorization by regrouping of terms. Example 1. Factorize a ab plus 4a minus 3b minus 12. B, ax plus bx minus ay minus by. Solution, a ab plus 4a minus 3b minus 12 can be written in groups as ab minus 3b plus 4a minus 12, which is equal to b in the brackets a minus 3 plus 4 in the brackets a minus 3. Here, there is no common factor of the terms, but on regrouping we get b common in ab and 3b, 4 in 4a and 12, which is equal to in the brackets a minus 3 in the brackets b plus 4. We notice binomial in the brackets a minus 3 is common in both terms. B, ax plus bx minus ay minus by is equal to in the brackets a plus b into x minus in the brackets a plus b into y, which is equal to in the brackets a plus b into in the brackets x minus y. Factorization using identities. Example 1. Factorize y square minus 9. Solution. Y square minus 9 is equal to in the brackets y whole square minus in the brackets 3 whole square, difference of two perfect squares, which is equal to in the brackets y plus 3 into in the brackets y minus 3. Using a square minus b square is equal to in the brackets a plus b into in the brackets a minus b. Example 2. Factorize 9x square y square minus 16. NCERT. Solution. 9x square y square minus 16 is equal to in the brackets 3xy whole square minus 4 square is equal to in the brackets 3xy minus 4 into in the brackets 3xy plus 4. Example 3. Factorize 16x raised to the power 5 minus 144x raised to the power 3. NCERT. Solution. 16x raised to the power 5 minus 144x raised to the power 3 is equal to 16x raised to the power 3 into in the brackets x raised to the power 2 minus 9, which is equal to 16x raised to the power 3 into in the brackets x raised to the power 2 minus in the brackets 3 whole raised to the power 2, which is equal to 16x raised to the power 3 into in the brackets x minus 3 into in the brackets x plus 3. Factorization of the expression that are perfect squares of the form x square plus 2xy plus y square or x square minus 2xy plus y square. When the given algebraic expression is the sum of the squares of two terms with twice the product of the terms added or subtracted, then it is factorized by using following identities. X square plus 2xy plus y square is equal to in the brackets x plus y whole square, which is equal to in the brackets x plus y into in the brackets x plus y. X square minus 2xy plus y square is equal to in the brackets x minus y whole square, which is equal to in the brackets x minus y into in the brackets x minus y. Example 1. Factorize x square minus 4xy plus 4y square. Solution. We have x square minus 4xy plus 4y square, which is equal to x square minus 2 into x into 2y plus in the brackets 2y whole square, which is equal to in the brackets x minus 2y whole square, which is equal to in the brackets x minus 2y into in the brackets x minus 2y. Example 2. Factorize a raised to the power 4 plus 2a square b square plus b raised to the power 4. NCERT. Solution. A raised to the power 4 plus 2a square b square plus b raised to the power 4 is equal to a raised to the power 4 plus 2a square b square plus b raised to the power 4 is equal to in the brackets a square whole square plus 2a square b square plus in the brackets b square whole square is equal to in the brackets a square plus b square whole square, which is equal to in the brackets a square plus b square into in the brackets a square plus b square. Factorization of quadratic polynomials. Example 1. Factorize x square plus 3x plus 2. Solution. From the expression, we have p is equal to 3 and q is equal to 2. So, we have to find two numbers whose sum is 3 and product is equal to 2. Because factors of 2 are 2 and 1, two such numbers are 2 and 1, as 2 plus 1 is equal to 3 and 2 into 1 is equal to 2. Thus, x square plus 3x plus 2 is equal to x square plus 2x plus 1x plus 2, which is equal to x into in the brackets x plus 2 plus 1 into in the brackets x plus 2, which is equal to in the brackets x plus 2 into in the brackets x plus 1. Example 2. Factorize x square plus 2x minus 3. Solution. X square plus 2x minus 3. Two numbers whose sum is 2 and product is minus 3 are 3 and minus 1, which is equal to x square plus 3x minus 1x plus 3 into in the brackets minus 1, which is equal to x square plus 3x minus 3, which is equal to x into in the brackets x plus 3 minus 1 into in the brackets x plus 3, which is equal to in the brackets x plus 3 into in the brackets x minus 1.